Exponential and logarithm functions. Just exactly what are they? Where did they come from? Let's start with where they came from. In the early 1600s, two mathematicians, Napier and Burgess, they went ahead and discovered exponential functions. They did it independently. In Napier, algebra, Burgess used geometry, but they realized that they have these functions whose outputs are a percentage of the original amount. And these functions are always either increasing or they're always decreasing. These are called monotonic functions. Now, to give you a sense of an exponential function, I can do so very easily because I can give you a percentage of the original amount that you're comfortable with, like doubling. If I go ahead and demonstrate this for you, it would just take a moment to put a visual in your mind that you'll never forget. What are the dimensions of this paper? 8.5 by 11. How about the third dimension? I said the third dimension. Third dimension. That's right. 0.004 inches. If I fold it and create a function based on the number of folds as the input and the output is the width, now I have one fold with a width of 0.008 inches, two folds with a width of 0.016 inches. If I fold 3, 4, 5, 6, I can't get the seventh, it would be half an inch. You say, show me the math. Gladly. Let's go ahead and do that. The function, we would use the model so that the input is nothing more than the number of folds and the output is the number of inches of the function. You would take the starting width of the paper. Was that the 8.5 by 11? No. Was that the 0.004? Yes, it was. And you would multiply it by 2 to the x, so that if I put a 1 in, 0.004 times 2 to the first gives me 0.008, that first width. And so with this function, if we were able to be strong enough, I can't, but if I was strong enough to continue to fold, what would end up transpiring? After 7 folds, we'd be at about half an inch. After 12 folds, it would be the height of the stool that you're probably sitting on. Well, after 17 folds, it would be taller than a one-story house, about 43.5 feet. After 22 folds, it would be the height of the Empire State Building, absent that antenna thing on the top. And if you consider this, after 32 folds, it's 271 miles. This piece of paper, thin, has just left the atmosphere. After 52 folds, it is now 300 million miles, and it has gone through the sun. And it turns out, after 100 folds, it has gone through the entire half of the universe, because it is now the width, and that width is the radius of the universe. Mind-boggling. Exponential functions, you gotta love them.